So we are going to talk about how the CPU processes instructions and executes instructions. And first of all, the CPU contains the control unit, the accumulator, the arithmetic logic unit, the other registers like the program counter, the current instruction count register, the memory address register, and then memory data register. On the right hand, we also have the memory where the instructions are initially kept. And taking a critical look, realize that the accumulator has been separated from the arithmetic logic unit, but they are the same thing. But for the sake of the demonstration, it has been separated for understanding. On the right hand, we have the memory and where the instructions are initially kept, but it's supposed to be in machine language, but then this is in assembly code, and also its content are written in a binary, but for the sake of demonstration, it has been turned upside down. Now, taking a critical look, this is what happens in the CPU. The program counter accepts the address of the instruction to be fetched, and that address is moved into the memory address register. And the content of the memory address register is stored in the memory data register, that is load 10. Load 10 moves into the current instruction register, but before that, the program counter will increase by 1 automatically. So that is to say that the program counter is always pointing to the next address of the next instruction to be fetched. Now, the instruction in the current instruction register is moved into the control unit to be decoded. And the instruction here is you should load 10. So the instruction will be decoded. And then before the instruction will be decoded, the 8 address is sent into the memory address register because you're about to fetch the another instruction, and its content is sent into the memory data register. And from here, we realize that the memory data register move into the accumulator. That is, the first set of instruction has been executed. So to move to the next instruction, the program counter is already pointing to the next address. So that address will be moved into the memory address register, and then the content will be moved into the memory data register, which is add 11. Add 11 from here will move into the control, the current instruction register, and then the current instruction register. Before that, the program counter was increased by 1. So the instruction in the current instruction register is moved into the control unit. That is add 11. Now, because you're going to fetch another set of instruction, the control unit will go and fetch the address of the add 11, the memory address 11, and will put it into the memory address, and so that its content can be fetched and input into the memory data register. Before that, the accumulator will send whatever it has there into the arithmetic logic unit for waiting for execution. Now, add 11, the memory storage 11, the content of memory storage 11 is put into the memory data register, that is 3. So from here, the memory data will send its instruction into the accumulator. For summation. So 3 is moved into the accumulator, and the accumulator moves it into the arithmetic logic unit for summation, and the answer is sent back into the accumulator again. So the second set has been completed. Second set of instruction is then completed. And then thirdly, their program counter is already pointing to the next address to be executed. So its address is kept in the memory address register, that is 102, and then its content, that is store 12, is moved into the current instruction register. Then we realize that the program counter will also increase by 1 by default automatically. So the current instruction register will forward its instruction into the control unit, that is store 12. That is store whatever is in the accumulator in the memory location 12. So memory location 12 address will be moved into the memory address register. That is, and with the help of the accumulator, the memory address register, the contents of the accumulator is moved into the memory storage location 12. And that is how the